Welcome to SolidCore. In this video, we are going to explain several of the most important commands in SolidWorks while drawing this water tank. Instead of drawing a circle and applying an extrude to make a cylinder, we can start from front view, sketch half of the cylinder profile with the opening at the top, and then set the dimensions. We have a 900 mm in diameter, so we will set our sketch to 450 mm from the origin point. After the revolution about this axis, this will give a full 900 mm in diameter. The total height is 2 meters. With the opening at the top being half a meter, so we will set 250 mm. And we have 100 mm as a flange height. Now go to the Features tab and select Revolved. In Axis of Revolution box, choose this line to make the sketch revolve about it. Now we have a fully defined sketch. Now to make the tank look more elastic and add the necessary structural strength to resist hydrostatic forces, we need to add the beading lines. Switch to front plane and draw a circle tangent to the cylinder's wall. Set its diameter and define its position 300 mm to the base. Now from Features, go to Revolved Cut to revolve the fully defined sketch about the center line. Instead of repeating these steps for the entire tank, simply we can use linear pattern from Features tab. In the Features and Faces box, choose our beading line. For direction 1, choose the vertical center line to define the axis of the pattern. Now set the distance between the beading line and specify the total number you need. It's that easy. Now to model these structural ribs, start sketching on the top surface. Use the Convert Entities tool and select your two existing circles to project them onto your current sketch. Next, draw a rectangle that consists of these circles. Turn the additional parts to get fully defined sketch. Set the distance between the two lines and the line with the origin points. Now from Features, select Extrude, set your desired thickness and hit OK. As expected, we won't repeat these steps manually to create remaining ribs. We will use the circular pattern command instead. Go to the Features and select Circular Pattern. In the Features and Faces box, choose the rib body you want to pattern. In Direction 1 box, select the tank body or the center line. Here you have two key options. Instance spacing. This allows to set the number of degrees between each pattern, in this direction or in the opposite. Equal spacing. This automatically divides your chosen degrees between the number of patterns. Choose the one that fits your design best. And you are all set. Now that we have finished the outer details, now let's activate the section view to inspect the interior. As you can see, the body is currently solid. To make it hollow, we will use the shell command. In the Property Manager, set your desired wall thickness. Select the top face you want to remove. In Faces to remove box. A common mistake here is thinking you have to fill in every single box. If a box doesn't apply to your design, just leave it blank. For example, here we just need to remove the top face. Now, if you need to adjust the thickness of a specific walls, like making the base thicker than the sides, use the multi-thickness settings box. Select the base and set your new value. Now, before we finalize everything, there's a critical rule. Always perform your shell command after you finishing all your external features, except for threads. Check this out. See how much the order of operations matters in your design tree. Watch what happens if I apply the fillet after the shell. We still have a sharp internal edge. Because the shell was performed first and doesn't see the fillets. But if I simply drag and drop the shell under the fillet feature in design tree, now the shell sees the fillets. And it automatically creates a seam lines professional internal transition. So always keep your shell command near the bottom of your feature tree, just before your threads, to ensure the internal details are clean and correct. You will notice the top is now open. The beading lines are perfectly formed, and you can clearly see the difference in thickness between the base and the tank walls. Now let's create threads on the outer body of the entrance. From manufacturing perspective, you always need to start with the chamfer on the edge. This makes the threading process much cleaner and smoother. Once the chamfer is ready, go to the Features tab and select Threads command. Select the circular edge where you want the thread to start. You can define the length of the thread as blind or set a specific number of revolutions. Okay, let's take a 10 mm as blind. Now let's look at specification. You might wonder what these numbers mean. Capital M stands for metric units. The 90, this is your nominal diameter. Note that in SolidWorks, even if you pick a standard size, the program will automatically adjust the thread to fit your specific diameter perfectly. The 6 is the pitch, the distance between each thread peak. Okay, now we get the thread ready. But look here. The cover won't thread on properly because the thread starts exactly at the edge we selected. To fix this, edit the thread feature in the design tree. Go to the offset option, set it to 10 mm and make sure it's offset above the selected edge. As a rule of thumb, always add a 10 mm to your required length to allow for this offset. Finally, go to thread options and always keep the trim options active to remove any additional unwanted threads. Notice the thread after offset. And you are all set. Okay, now it's your turn. Here is a new sketch with a similar challenge. Try to fully define it using the techniques we just covered. In the next video, I'm going to make a quick, silent walkthrough of the solution. Good luck!